What's good, everybody? Professor Peters here. Today, I'm going to teach you guys two situations with radicals: how to do the basic, break down and simplify them, and how to simplify radicals in more complicated situations when there's variables and exponents included. So, we're looking at our first problem, radical 32. And understand, guys, radicals, we are basically trying to use the concept of division. We're trying to break it down with division, and we want to focus on using perfect squares. So right now, I'm writing down the factors for 32. 1 times 32, 2 times 16, and I believe 4 times 8. So we're going to focus on these two. So when I look at this problem, let's say we wanted to break this radical down with 4 times 8. So the only perfect square right here is 4. So once we simplify, this turns into 2 radical 8. But we could break 8 down even further because there's a perfect square that goes into it. So now we're going to have 2 times radical 4 times radical 2. Because this is a perfect square, it turns into 2, and our final answer will be 4 radical 2. But let's say that we did the problem correct, and in the very first step, we use the largest perfect square that goes into 32. What would happen? So let's do that down here. So when we break down this radical and use the largest perfect square, we're going to have 16 times 2. Perfect square, we take out its square root, and our final answer would be 4 radical 2. So this is why we stress using the largest perfect square, because it's less steps, and we know less steps mean we're less likely to make a mistake. So let's go over to our second problem. So we're talking about 5 times radical 125. So anytime you have a number outside, just remember, if there's any perfect square that comes from under the radical, we're going to multiply. So right here, this is exactly what I'm talking about. 4 turns into 2. Since it's a perfect square, we multiply by that 2 that is already there. That's how we got 4 radical 2. So I'm looking at this, and I know that 25 is the largest perfect square that goes into 125. And I got to multiply it by 5. So when I break this down now, I know this is a perfect square, and it's going to turn into 5. So the final answer for 5 times radical 125 would be 25 radical 5. All right. Problem number 3. We have the problem that says 4 times radical 108. So when we look at this problem here, I know the largest perfect square that goes into this is 36. So what exactly do we multiply 36 by to get 108? It's going to be 3, right? Perfect square, we're going to take it out, turns into 6. We multiply that with that 4 that's already on the outside. Final answer would be 24 radical 3. So this is the basic foundations of how to simplify radicals, right? Number 1, write out all your factors. 2, pick the largest perfect square that goes into that radical. And in 3, break it down to its lowest terms or simplest terms. Meaning you can't break it down no more. All right, guys, so we're on part 2 of the video, meaning I'm going to start talking about how to simplify radicals with variables and exponents. But before I do that, if you found this video helpful, I'm just going to ask that you smash the like button for us, subscribe to the show, and leave any comments for future videos you guys would like to see. Really helps with us sharing and getting more people to see our videos. So to start this off, guys, we need to focus on this important concept. The square root of x squared is x. So the way I'm going to teach this is we're going to use x squared. How many x squareds are in 5? So we have x squared times x squared times x. Because when we multiply exponents with the same base, we just add the exponents. So we have 2, 4, and 5. So now we could simplify. So we know the square root of x squared is just x, and the square root of x squared again is just x. And we can't find the square root of just x, so we leave it under the radical. So as a result, when we clean this up, our answer would be x squared radical x. And we're going to apply that same concept to the second problem. So we have 9 times k squared times k squared times k squared, right? And we know 9 is a perfect square, so we take it out and this turns into 3. And we're going to repeat the same exact thing for k. So we're going to say times k times k times k times k and times k again. And we could simplify this to 3k to the 5th power. So this is the basics. After you start getting used to it, guys, there's another way to solve this. And this is what I tell my students. So you can just take the square root of 9, which is 3. And if you have an even exponent, just divide it by 2. So this will be 3k. And if I divided my exponent by 2, to the 5th power. And we get the same exact answer, right? But in my third problem, I'm going to show you a problem where we don't have even variables. Even exponents. What exactly do we do? All right, guys, my last scenario for today. So we have a more complicated answer with higher exponents and odd exponents, which makes it a little bit complicated. So this is the best way that I teach my students. I hope you guys find it helpful. So the way that we're going to break this down, right, is we're going to look at the number first. And let's think about the factors that we're going to use, right? So we have 9 times 3. I know 9 is going to be the largest perfect square that goes into 27. After we determine the factors, I tell my students, please make sure you guys are listening, to split your exponents. Meaning, I'm going to put all my even exponents with my perfect square root. So we have x to the 10th. Y to the 5th, I'm going to put the highest even exponent number. So that would be y to the 4th. Right? That 5th y, I'm going to leave it with the basically unperfect square. And then I'm going to do the same thing for z17. So the highest even number before 17 is 16. And then we have that 1z left over. Mr. Peters, why do you do it like this and teach it this way? Because it makes it simpler. So let's focus on this part, right? So we have -8 multiply, square root of 9 is 3, square root of x to the 10th power. Remember, we just divide the exponent by 2. X to the 5th, y to the 4th turns to y squared, and then z to the 16th turns to z8. And then we're multiplying this by 3yz, because we cannot take the square root of 3y to the 1st power or z to the 1st power. So this part right here is done. Let's clean this up by multiplying our coefficients. So -24 x to the 5th y squared z8 radical 3yz. So this is how you guys would solve this problem. And when we look back over it, right, let's look at it. If we divide our exponents, it's x to the 5th. This is y to the 2 with 1 left over. That's how we get 5. Z to the 8th, right, 16. And then when we add that 1, we're going to get 17. So hopefully you guys found this video review helpful on radicals and how to simplify. We hope that you guys enjoyed the video. Smash the like button on your way out for us and join us next time. Thank you guys so much.